Alright, number 52 on page 432 is similar in setup for as 50 itself. So 52 looks like we've got a 35 meter high window, and you've got angle of depression to the top of a pole, nearby street light, and then angle of depression to the bottom. So the way we set that up, we've got 35 meters high. We're going to go over some distance. Got a street light. We want to know this distance x. What they tell us is the angle of depression to the top and bottom. Just going to kind of let's do better than that. Okay, so angle of depression to the top is is 55 degrees, and angle of depression to the bottom 57.5 degrees. Okay, how do we go about starting this one? Well, if we look at how we find our x in the end, it's really part of a bigger triangle. So let's pick bright purple here. If we make this triangle right here, the orange triangle, which I'm now making purple, that triangle looks like this. $57.5 here, 90 here. Now the length of this side here we know is 35 meters. If we can find, let me call this y. If we can find y, what we can do with that is create another triangle that is just this distance. Nope. My pen will work. Okay. It seems as though Windows Journal is not working, so let's try this. Okay, I figured out the Windows Journal issue there. So anyways, what I was saying is, if I can get this triangle, let's make it green actually. Right here, our green triangle, we know 55 degrees, 90 degrees, this would be y, and let's call this z. Well, if we want, in the end, if we want x is the distance, the height of our street light, x is really our 35 meters tall distance. Nope, sorry, that's not y, that's z. So 35 minus z gives us our x value. So based on this little purplish pink triangle here, we can find our y value. Once we find y, we can plug it in here, and then we have our only one unknown, our z. And then you just take 35 minus our z distance. So let's do that. Finding our y value. So our 57.5 angle is 35 is opposite, y is adjacent, so tangent of 57.5 is 35 over x. Come over here, we've got, I keep using X, that's just kind of a standard for me. That's actually Y. So once we find Y, we'll plug it in. Over here we've got tangent of 55. Sorry about that. Equals Z over, I'm going to leave that for now. We'll find Y to be 35. I'm going to plug it in my own calculator. 35 over tangent 57.5. You get 22.297. Now, I guess just for the time being, I'm going to leave that as Y. Solve for Y. I'm sorry, solve for Z. If I can do that, I'm going to leave, the reason I did that is I'm going to leave that answer from the 22.297. If I leave that whole answer, 22.297,45913, I'm going to get a more exact Z distance. So I'm going to leave that 22.297. I'm just going to continue on and say times tangent of 55. Z is then 31.844. If we bring that up to this equation, x is equal to 35 minus 31.844. Again, in my calculator, I can just type 35 minus and then second negative key to get my answer. And I get 3.156 meters. So that is your distance. I think the textbook is a little bit, there's a bit of a rounding difference, but just over 3 meters is the height of your street light.